so this particular presentation is about the key differences between the static friction and the kinetic friction. Okay, so let's start with the definition. Static friction is there when you are trying to move the two bodies over one another, but the bodies don't move. In the case of kinetic friction, the bodies are already in relative motion. That means there is a motion between them. But in the case of static friction, this is a friction that basically resists the initiation. That is the beginning of the motion between the two surfaces. So the motion has not started. Okay, as you can see, the second point, this basically acts on the body which is at rest and does not allow it to move. Whereas the kinetic friction acts on the bodies which are already in motion, in relative motion with respect to another body. What about the magnitude? The magnitude of static friction is not fixed. It purely depends on what is the external force you're applying, and it will adjust. And the maximum value of the static friction you can get is mu s into n, where mu s is the coefficient of static friction. Whereas in kinetic friction, the total friction which is there when you're moving over one another and there is a relative motion and friction exists is mu kn, not mu s, and it is a fixed value. Okay, mu kn, n is of course a normal reaction, but if you notice the static friction, you don't have an equal to sign only, you have less than also. So kinetic friction is fixed if you have a mu k and n known, but you can't fix it for the static friction because static friction takes place when the body has not moved. So if you apply 5 Newton of force, the static friction will be 10 Newtons, sorry, 5 Newtons only. If you have 10 Newtons of external force, the static friction will adjust to the 10 Newtons. So say the maximum static friction which is available to you is the product of mu s into n is equal to 15. I will just help you understand this with the help of an example also, but just listen through this. So the difference essentially is in the magnitude also, not only in the way it acts, but also the magnitude. The static friction you can see is very adjustable. Now, what about the coefficient of static friction? The coefficient of static friction is referred to as mu s, and the value of static friction coefficient is higher than the coefficient of kinetic friction. What is the nature? This is what I was referring to. This is the most important point if you understand for JEE Mains preparation. Highly conceptual point if you're new to this chapter, that static friction is self-adjusting. It depends purely on the applied force, and then of course it reaches the maximum value of mu sn, but before that it is always equal to the external force you have applied. So it is self-adjusting, whereas kinetic friction, as we already discussed, is always constant for a given pair of surface. It will not depend on the relative velocity, right? And then of course, what is the effect? Static friction does not allow the body to start even. There is no initiation. Whereas in the case of kinetic friction, what will happen is the bodies will start, they will move. It is always, the two bodies have to be in relative motion. And so the job of kinetic friction is to oppose the motion, not prevent it, right? So static friction is there to prevent the motion, whereas the kinetic friction is there to oppose the motion, not prevent it. What is an example? So if you have a body, you're pushing it, it is not moving. So the body is having a static frictional force at the surface where it touches the ground. Now in the case of kinetic friction, if you push the body will move and will have a relative motion with the ground. It will show you the sliding effect. Okay, so you are pushing with 5 Newton, the kinetic friction is 3 Newton, and the total force on the body is 2. Okay, you already understand the formula. Let me do one thing. Let me just draw a simple situation so that you can understand what exactly is happening in the case of the static friction, okay, and the kinetic friction. With the help of a small diagram, I will explain you. Uh, if you want to watch more videos on this topic, you can go to my playlist. This is basically a high level conceptual video just focusing on the difference between the two. Okay, so let's say you have a situation where there is a block. Okay, so you have a block, and what you're doing is uh, applying an external force. Okay, I'll just draw the block here. So this is your block. Okay, this is your block, and the block is lying on a surface like this. Okay, what you're doing is you're pushing it with a force which is F. Okay, and what you find is the block does not move. It doesn't move. If the block doesn't move, what it has here is the prevention of motion, and what it has is a static friction. Okay, so this is the external force you applied, right? It does not move. So you increase, so for example, you applied 1 Newton force here. It did not move. So the static friction will also be 1 Newton. Then if you apply 2 Newtons, the static friction will always be 2 Newton. Then you apply 3 Newton, the static friction will be 3 Newton. Then you apply 4 Newton, the static friction will be 4 Newton. This is the way static friction keeps on adjusting based on the external force you apply, right? And then what happens is it attains the maximum value, which is given by the formula. Friction static maximum is given by the product of coefficient of static friction and the normal reaction. So mu s into the normal reaction. So this is the weight of the body, mg, and the normal reaction on the body is upwards, given by n, right? So n is equal to mg, n is equal to mg. Okay, the normal reaction is the force which comes from the ground to the body. So F n is equal to mg, right? So what you do is, if you're given the value of the static friction, say 0.5, and you're given the value of mg also to be, for example, it is given to be 10 newtons or 5 newtons. Multiply it, say 10 newton is the value of the weight, 10 newton. It's a 1 kg mass, multiply by 10 meter per second square acceleration due to gravity. So 5 newtons is a normal reaction. So you will get 0.5 into 10 is equal to 5. So this is the maximum static friction available between the pair, after which the body will start moving, right? So 5 Newton is the maximum you can go before you start moving. So this is the way static friction is said to be self-adjusting. It will adjust itself to the external forces and then reach the highest force. When it reaches the highest force, after that the kinetic friction comes into play. And we know that the kinetic friction is a fixed number. It is given by mu k n, right? So it is not self-adjusting. It will become fixed. And the value of the kinetic friction is less than the coefficient of kinetic friction is less than the kinetic friction, which is, the static friction coefficient. So generally when the body has started moving, it requires less force for motion as compared to the force required to start. So if the start force is 5 Newton, okay, if the start force is 5 Newton, you apply 5.1 Newton, the body will then start moving, right, with some force at least, right? So if you apply 5.1, the body will start moving, and the external force will become 5.1. The frictional force will be what? For example, let me give you an example when the body starts moving also. Okay, let's insert another slide and see what exactly happens. Okay, so let's say the body has now got a force which is given by, okay, let me just explain you this concept, that the body has now got a external force. So we know that maximum stationary, the static friction which is available to you, okay, is of a certain magnitude. And now what we have to do is use it to draw a situation where the body is moving now, and we are supposed to focus on the, so let's say this is your block. We know the maximum force it can have is 5 newtons after which the motion will start. So I am applying now 5.1 Newton to it. Okay, so this is my 5.1 Newton force. Okay, I think the cursor is taking time, so it is not visible. 5.1 Newton. Now we know the kinetic friction has come into play because you have already exceeded the value. Okay, you have already exceeded that value, which is the static frictional value. So let's say now the kinetic friction is F kinetic is equal to 0.4 multiplied by 10 because 0.4 is a kinetic friction. So the total kinetic friction available to you is equal to 4 newtons. So this is 4 Newton, and therefore the net force on the body is 5.1 minus 4 Newton. Right? This is 5.1 minus 4 Newton is equal to 1.1 Newton. Right? So you note that if you cross the static friction, the maximum static friction, then you have to apply the equation of motion, which is the Newton's law of motion, which means the F external minus the frictional force is equal to ma. So this is equal to ma. If you know the mass of the body is 1 kg, the acceleration will come out to be 1.1. Right? So this is the way you need to think about. So the frictional force increases, it reaches the highest value, and then a certain dip comes after which the frictional force becomes constant. Okay, so this is the way this behaves. This is your static friction. It reaches the highest value, dips, and then becomes constant after the maximum static frictional force is overcome by the external force. You come into the region of kinetic friction. So I hope this made sense to you. Very basic concept. You should know the differences between the kinetic frictional force and static frictional force. If you're preparing for JEE Mains and you are in foundation, this is very useful video for you. Thank you very much and wait for my next video.